All right, today we are getting right into the nuts and bolts of structural integrity. We're going to break down the specific methods for tightening preloaded bolting assemblies, all according to the BSEN 1439 standard. And we'll be focusing on that crucial K-class system, K0, K1, and K2. Now, all the information we're covering today comes from this guide, which was prepared by the experts over at Andrews Fasteners Limited. These folks really know their stuff, so you can be sure all the procedures we're about to discuss are based on a deep understanding of the official standards. Okay, before we dive in, we have to cover the official disclaimer from the guide. I'm going to read it to you exactly as it's written. Whilst the information is provided in good faith, Andrews Fasteners Ltd. are not under any responsibility or liability in respect of errors or information that was found to be incorrect or for any reliance the user may place on it. So the key takeaway there is, this is an excellent guide, but you always have to ensure you're following the precise requirements for your specific project. So here's our game plan. We'll start with understanding the K-class system itself. Then we'll walk through the specific methods for K0, K1, and K2, one by one. And finally, we'll wrap it all up with a summary of the most important points. First things first, let's get to the heart of it all, the K-class system. Getting this right is pretty much the foundation for everything else when it comes to tightening high-strength bolts correctly. So what in the world is K-class? Well, the standard says it expresses in a concise way the ability of the bolting assemblies to be tightened by the specific method. In plain English, it's basically a code that tells you how a specific bolt, nut, and washer combo is designed to be tightened up to get the perfect amount of preload. And this table here lays out the three classes really clearly. For K0, you're using the direct tension indicator, or DTI method. For K1, you've got the combined method, which is a mix of torque and a partial turn. And for K2, it's the torque method, which, as you'll see, uses two different torque settings. Now, before we get into the nitty-gritty of each one, there are some golden rules that apply across the board. You can use a K2 assembly with a K1 method, that's fine. But you can't go the other way. You can't upgrade a K0 or K1 without a proper assessment. And this next one is absolutely critical. You are obligated to use the torque figures supplied by the manufacturer for that specific batch. No winging it. And remember, every single time, you start with proper surface prep and by getting all your bolts to a snug, tight condition in a set pattern. All right, let's jump into our first method. This one's for K-class K0, and it's all about using the direct tension indicator, or DTI. The whole principle of the K0 method is that it's completely mechanical and visual. You're not using torque wrenches for the final tightening here. Success is all about physically squashing these little bumps on a special washer and then checking the gap with a feeler gauge. It's really as simple as that.
So the procedure is very methodical. First, you tighten each bolt just enough to get it snug tight, and you'll actually see the little bumps on the DTI washer start to deform a bit. Once you've done that for every bolt in the connection, you go back and do the final tightening to really compress the washer. The final step is your inspection. You take a feeler gauge and count how many times it's refused, meaning how many gaps it just can't fit into anymore.
And this table is your cheat sheet for that final inspection. It's super simple. You just count the number of little bumps or protrusions on the DTI washer, and the table tells you the minimum number of times your feeler gauge has to be refused. For instance, if you have a washer with 6 bumps, you need at least 4 refusals to know you've hit the right preload. Done and dusted. Okay, on to our second category, K-class K1. This is what's known as the combined method, and it's called that because it mixes two different techniques, torque and a part turn. The idea here is a two-step process. First, you use a properly calibrated torque wrench to apply a specific initial torque called T1. And that T1 value has to come from the manufacturer for that exact batch of bolts. After that's done, you apply a final specific amount of rotation, the part turn. Now, we've said snub tight a bunch, and it's so important for both K1 and K2. So what does it really mean? The guide defines it as that achievable by the effort of one man using a normal-sized spanner without an extension arm. It could also be the point where an impact wrench just starts to hammer. The main goal is to be consistent without going overboard. So the procedure for K1 goes like this. 1. Get every bolt to that snug tight state. 2. Use your calibrated torque wrench set to that T1 value from the manufacturer on all the bolts. 3, and you don't want to skip this, mark the nut's position against the bolt. Finally, you apply that required part turn, and your mark is the perfect visual guide to know you've turned it just the right amount. So, how much do you actually turn it?
You don't guess, you use this table. It all comes down to the total thickness of the parts you're clamping together, which is T, compared to the bolt's diameter, which is D. So if that thickness is less than twice the bolt's diameter, you give it a 60-degree or a 1/6 turn. As the material gets thicker, the amount of rotation you need goes up.
And that brings us to our final method, which is for K-class K2 assemblies. This one is the pure torque method, sometimes called the double torque method.
Unlike K1 that mixes torque and a turn, the K2 method is all about torque. The manufacturer gives you two different values for that specific batch: a first stage torque, T1, and then a final higher torque, T2. The procedure here is really straightforward. Like all the others, you start by bringing every single bolt to a nice, uniform, snug-tight condition. Then you set your calibrated wrench to that first T1 value and go through and tighten all the bolts in your pattern. Finally, you adjust your wrench up to that second final torque value, T2, and you go over all the bolts again in the exact same pattern to get them to the final preload. Okay, now that we've walked through all three methods, let's just take a moment to summarize and really hammer home the most important principles for a safe, correct installation. Let's do a quick recap. K0 is purely mechanical. It's all about that TTI washer and your feeler gauge. K1 is the combined method, one torque value T1 plus a specific rotation. And K2 is the double torque method, using two separate values, T1 and T2. And remember, for any method that uses torque, you absolutely must use the figures provided for that specific batch. And you always start with a systematic, snug tightening of the whole connection. And hey, if you're looking for more resources or maybe some helpful tools for these procedures, the folks at Andrews Fasteners recommend checking out their website at the short link you see right here. And we'll leave you with this one final thought. Getting the preload right isn't just a recommendation. It's absolutely fundamental to structural safety. So the question you should always be asking on site is this: is every single bolt in this connection tightened correctly and to the specified standard? Thanks for tuning in,